Hi class, I'm going to illustrate drawing Lewis structures for polyatomic molecules and ions. The first step in drawing Lewis structures is to count the total number of valence electrons present. In order to do that, all you do is sum up the number of valence electrons from each atom. For example, in H2S, each hydrogen contributes 1, so we have 2 times 1. And then each sulfur contributes 6, so plus 6. So that would be a total of 8 valence electrons in H2S. In oxygen difluoride, we have a total of 6 valence electrons from the oxygen. And then we have 7 valence electrons from each fluorine. And that equals a total of 20 valence electrons. In the ammonium ion, we have 5 valence electrons from each nitrogen, and then we have 1 from each hydrogen. However, in the ammonium ion, it's a polyatomic ion with a positive charge. In order to have a positive charge, that unit as a whole must have 1 less electron. So we're going to subtract off 1 so that we have a plus 1 charge on the whole thing. And that equals a total of 8 valence electrons. In carbon tetrachloride, we have 4 coming from the carbon, and then we have 7 coming from each chlorine, and that totals to 32 valence electrons. The next step is to choose the center atom. This usually can be done by deciding how many bonds need to be made in order for that molecule or the atom in that molecule to complete its valence. For example, sulfur is in 6A. In order to be like the closest noble gas, it usually wants to form 2 bonds. We're going to see some exceptions, but usually it'll form 2 bonds. Hydrogen can only possibly form 1 bond. It's in 1A. In order to be like helium, it will form 1 bond, no exceptions. Oxygen is in 6A. It tends to form 2 bonds to be like the closest noble gas. And fluorine, with no exceptions, can only form 1 bond to complete its valence. Nitrogen usually forms 3 bonds. Carbon, 99.99% of the time, carbon will form 4 bonds. Chlorine, usually, there are some exceptions, forms 1 bond. So using the valence rule, you can also usually predict bonding. Just remember this, hydrogen and fluorine will never be center atoms. If carbon is a choice, it'll always be in the center. Okay, so for H2S, sulfur is the center atom. So we're going to draw in the center atom for each of these. In OF2, oxygen is the center atom. In the ammonium ion, the nitrogen is the center atom. And when you draw polyatomics, it's common to indicate the charge outside of a bracketed species, so showing that that charge is on that entire species. In carbon tetrachloride, the carbon is the center atom. The next step in drawing Lewis structures is to add in the surrounding atoms. And so we'll just write in our hydrogens here, fluorines here, 4 hydrogens surrounding here, and then our chlorines. Okay, after you've added in the surrounding atoms, you're going to connect them to the center atom with a single bond, and then subtract what you use from the total count of valence electrons. So connect those with a single and subtract. Remember that a bond represents 2 electrons. So this would be -4, and we have 4 left. For here, add in 2 single bonds, subtract what we used, we have 16 left. Here we'll draw in 4 bonds. We used 8, we have 0 left. And then in the last example, draw in 4, we used 8, and we have 24 left. After you've done this, what you want to do is give the terminal atoms a complete valence if they do not have one. In the first example, H2S, the hydrogens already have a complete valence. Remember, hydrogen wants to be like helium, and helium only has 2 in its valence shell. So the first one, there's nothing to do there for this step. In OF2, fluorines are going to have 8 electrons around them in order to complete their valence. So they already see 2 because they have a bond to oxygen. So we're going to add in 3 lone pairs. We're also going to subtract what we used. In the ammonium polyatomic ion, the terminal hydrogen atoms already have a complete valence. So there's nothing to do there. For carbon tetrachloride, each chlorine is going to need 3 lone pairs, so each chlorine sees a total of 8 valence electrons around it. Then we subtract what we used. And we have 0 remaining. The last step is to take any remaining electrons in your count, any remaining valence electrons, and put them on the center atom as pairs. So in H2S, we have 2 pair left for a total of 4 valence electrons. And we subtract what we used, we have 0 left. In oxygen difluoride, the same story. We have 4 left, and we're going to put those on the center oxygen. In the ammonium polyatomic ion, we don't have any left, so there's nothing left to do. And in the carbon tetrachloride molecule, there are no valence electrons remaining, so there's nothing left to do. The last step is just to check your work. Make sure you used all your valence electrons. Make sure that each center atom has a complete valence and each terminal atom has a complete valence.